So this is a basic stoichiometry problem. We're given an amount, in this case volume, of nitroglycerin. It's a liquid, and we want to know how many moles of gas are produced. Typically in stoichiometry problems it asks about a particular product, but in this case it's asking about all of the products. So in any stoichiometry problem you've got to convert to moles first. And so in this case we've got to use the density to convert volume of nitroglycerin to grams, and then we use the molar mass of nitroglycerin to convert grams to moles. So at the end of this calculation we end up with the number of moles of nitroglycerin, which is 1.402 times 10 to the minus 2 moles. So now let's look back up to the equation. All of the products are gas, and so if you add up all those coefficients, there are 29 moles of gas on the product side. And so we have a ratio of 4 moles of reactant, that's the nitroglycerin, to 29 moles of product. Now you might think, how can you go from 4 to 29? Well, look at all the atoms that are in nitroglycerin. Right? There's a lot of carbon, hydrogen, nitrogen, and oxygen, and all of those get separated into a variety of different compounds. And so it's possible for this to happen. So now we just need to take our moles, use the ratio of 29 moles of gas for every 4 moles of nitroglycerin, and make a very basic calculation. So now that we've got the number of moles, and we know there are 29 moles of gas for every 4 moles of nitroglycerin, we simply set up the problem so that we use the conversion factor correctly, so that our units will cancel, and we end up with the correct answer number of moles, which I believe is 0.102 moles of gas. From the previous problem, we know that 0.102 moles of gas are produced. And then in this problem, we're told that each mole occupies 57 liters. So using that as the conversion factor, we can calculate that 5.8 liters is the volume that that gas occupies. And this question is purely a standard stoichiometry question. Convert to moles, use a mole ratio, convert to the units you want. Well, we're already in moles. We know that we have 1.402 times 10 to the negative 2 moles of nitroglycerin. That's the Ng that I have there. Got tired of writing the whole formula. We use a mole ratio to convert from moles of nitroglycerin to moles of nitrogen gas. And then we use the molar mass, 28 grams of N2 per mole of N2. Punch that into our calculator and we get 0.589 grams of N2. 3 significant figures because of the molar mass, 28.0 grams of N2.